Welcome to this introduction to configuring networking in Sunlight. In this video, we will cover the various options for attaching a Sunlight cluster to your network, from the simplest configuration through to more complex options, which can support fault tolerance and redundancy. We will explain how network and storage traffic for workloads are optimized and managed in the Sunlight system. Let's get started. Configuring the network layer in Sunlight is simple, and getting up and running is quick and easy. Sunlight is designed to work out of the box with sensible default settings. You should think of the virtual network sublayer in Sunlight as an extension to the physical fabric. Every physical NIC on a Sunlight host can be accessed directly, or can be bundled as a redundant path for a virtual SDN network to carry isolated traffic securely between workloads. There are two types of virtual network in Sunlight. First, a VLAN-enabled network that connects to your switch fabric and allows you to send VLAN-tagged packets over any physical NIC path and with any VLAN network ID. Second, a private Sunlight network that encapsulates traffic and tunnels it between nodes in a Sunlight cluster. This network type does not rely on any switch services, such as VLAN tagging or NIC teaming, and allows you to scale up your network bandwidth by simply adding more physical NIC paths into the logical VNet. Every virtual network can be configured with additional attributes to make routing and access easy. Some examples are making a network routable via the Sunlight cluster controller, making a network routable via a third-party network router function, applying a network address translation policy for outbound traffic, enabling a DHCP service for the network subnet, configuring a static IP allocation policy for VM types that support auto-configuration, disabling DHCP, and allowing an external third-party service to provide the DHCP address allocation. Let's look at some of the configuration options, beginning with the simplest network configuration. Every physical host has a minimum of 2 NICs attached to a simple 10 gigabit switch. The switch is configured to provide a flat VLAN where all the ports are tagged to the same logical VLAN ID. Alternatively, this can be a non-smart switch that has no VLAN support at all. DHCP is enabled on this switch subnet, and it allocates an IP address, default gateway, DNS setting, and provides a routable network connection to any endpoint that requests it. This might be as simple as a small office class router. The Sunlight dashboard service connects to this subnet and acquires a DHCP address, which enables you to securely connect a web browser to the dashboard in order to manage your cluster and attach it to a Sunlight application marketplace instance. Layered on top of the physical network interfaces, you can create one or more Sunlight virtual networks that utilize as many physical NIC paths as you choose to select. Note that these are active networks, and the bandwidth is aggregated across all the chosen paths. Now you can deploy as many workloads as required. You can create as many virtual NIC interfaces as you wish and attach them to any network on the cluster. That may be a physical network routing traffic directly out to the Ethernet switch, or an internal private network that manages all the MAC address learning and forwarding internally within the Sunlight cluster. Even though a private network is redundant and works in an active mode, what if we want to add some redundancy to the whole system? Let's introduce a second redundant switch. We'll connect one physical NIC port into switch 1, and the second physical NIC port into switch 2 for each host. The Sunlight network configuration remains exactly the same. We can still create one or more Sunlight virtual networks and attach to the physical network paths. For any workloads that require to be attached directly to the physical network ports, you can multi-home the workload to more than one physical network path and create a NIC team over the pair of connections. Also note that the Sunlight cluster dashboard is fully redundant and can be enabled to failover to another node in the event that it is inaccessible. Let's look at a VLAN-enabled configuration, which might be more common in an enterprise data center. If you choose to enable VLANs when you first set up your Sunlight cluster, the node will automatically be configured with VLAN tagging enabled for the cluster management traffic. Note that you can configure any VLAN ID you wish to use for management traffic. By default, Sunlight will configure the first physical 10 gigabit NIC on the system as the active path, and will bundle the additional NICs as passive failover paths for each. All this configuration is taken care of for you, and you do not need to make any adjustments. Note also that active-passive path configuration does not require any switch configuration, such as NIC teaming across physical ports, because Sunlight is careful to only ever advertise a unique MAC address out of the same single NIC path, except in the case of path failure such as a cable pull. In that case, it will proactively advertise the MAC address on the passive path to force the switch fabric to learn the new path. Now you can configure both types of virtual network. VLAN-enabled logical networks with a specified VLAN tag, or Sunlight private networks that, as previously described, utilize as many physical network paths in an active-active mode configuration as selected. In this manner, you can attach workloads directly to your switch-enabled VLAN fabric, or you can keep workload traffic isolated and communicate only between Sunlight cluster nodes. As before, you can now deploy your workloads and attach them to either a VLAN-tagged network or a Sunlight private network. The whole network stack is completely redundant and tolerant to network path failure, individual switch failure, and complete host failure, where the workloads will restart on another host, along with the Sunlight cluster dashboard service. What if you would like to utilize a third-party network function, such as a virtual router or firewall function? It is as simple to enable as the standard network setup I just described. You create the virtual network function workload and attach it to whichever logical networks you choose. The network function can route traffic from internal private networks to an external upstream gateway, and can be configured to apply whatever type of firewall policy, port forward logic, VPN endpoint termination, and so on, that is required. If you want to deploy a virtual network function, we recommend you start with the Sunlight Application Marketplace, where we have a number of pre-configured appliances to simply drop into your Sunlight cluster. In our previous descriptions, we explained a simple host setup with 2 NICs. However, it is important to note that you can add as many physical NICs as you wish in order to increase the bandwidth and add greater levels of redundancy. As you add more NICs, you also have more choice as to how you configure the network traffic flow across the virtual networks you create above them. We're showing here the non-VLAN enabled mode, and are depicting 2 virtual networks consuming different numbers of physical NIC paths. Private VNet 1 utilizes 2 paths of 10 gigabit each in an active-active mode to provide a 20 gigabit channel, while Private VNet 2 utilizes 4 paths of 10 gigabit each in an active-active mode, in other words a single 40 gigabit channel. And finally, this is the VLAN-enabled multi-NIC configuration, with a similar result, but utilizing VLAN-tagged networks enabled by the switch infrastructure. Don't forget to permit the VLAN IDs that you wish to use on all the physical network paths, otherwise the switch may not allow the tagged packets through. Now let's switch to the storage aspect of the host. I will now describe how the I/O traffic is transmitted over the network. Firstly, we consider the logical components of Sunlight NextVisor. By default, on every host there is a Sunlight virtual network configured that is dedicated to storage traffic. This network is configured to utilize all the physical paths of the host for remote replication of data. The virtual block switch resides in the VMM layer of the NextVisor and manages the logic for reading and writing of data, and for ensuring that all data is atomically written to all replicas of the virtual drive. The virtual block switch is also responsible for both physical network path and drive failure detection, and for making decisions about how to transmit data, and when to fence copies of the data set, in the event of failure. So let's consider the data path for a virtual block device that is presented to a virtual machine. The virtual block device is presented to the VM with a specific number of virtual sectors and a sector size that determine the capacity of the virtual device. That virtual device is represented in the virtual block switch that resides on the same host as the VM. The virtual block switch knows about where the physical copies of data reside, and for each copy, whether it resides on a local or remote address. Local reads and writes hit the locally attached drive immediately, utilizing the Sunlight optimized I/O path logic. For virtual drives that are configured with replication enabled, the virtual block switch also handles the remote replication of writes across the physical network, at the lowest possible latency. The switch understands the optimal networking paths of the physical host, and will create local and remote NIC pairings to transmit data packets. An outbound write request will traverse a local path destined for remote NIC, where it will be handled by the virtual block switch. It will then be optimally mapped to the correct locally attached drive. The same is true for every logical NIC path available between the hosts. The virtual block switch will transmit an outbound write request over each logically connected and healthy network path to parallelize the transmission of the data packets and to minimize the network transmission latency. The good news is that all this optimization and clever routing is managed for you. All you have to do is power on a cluster, attach it to your network, and then let Sunlight do the rest. Give Sunlight a free trial today. We'll show you how quick and easy it is to get the fastest infrastructure platform on the market up and running. We'll have you deploying your workloads from start to finish in under 10 minutes, whether that's on premises, in AWS, or at the edge.